Good.
Good. Yeah.
Okay, reaction mechanisms. All right, guys, so this is an analogy that we're going to use a lot. It's like building a house. Has anybody done any renovations lately? Raise your hand. Yeah, okay, you know what I'm talking about, okay? So if you have contractors and they do different things, and it's an analogy, so forgive me a little, okay? When you're building a new molecule, if you're like building a house, you actually don't do it all at once. So they don't put in the foundation, pour the basement, frame the house, do the roof, put the walls, put the windows, put the doors in, and paint it on the same day or at the same time. You've got steps that need to be done 1, 2, 3, 4, right? So you got, at some point, you got a house with walls and there's tar everywhere, but there's no siding and there's not a proper roof. And maybe the windows aren't in properly and they're just boards for a little while. So you have your framing, you've got your windows and your doors and your roof, and they all come in with different guys or gals contracting it in, okay? So what they're saying is that everything in a reaction to make a particle or product, it doesn't happen all at once, and it actually usually has to happen in a specific sequence of steps, okay? Each step has its own rate. So I also do another analogy for this is dishes by hand. So if you're doing dishes by hand and you have like a brother or a sister and one of you is drying and one of you is washing, this is the simple analogy. It doesn't really matter if you're washing and you wash really quickly. You're not going to be done the dishes if the dry person is really slow. And if your mom is real strict like me and they're like, you have to be done all the dishes before either of you can go dirt biking. I don't know, right? You're washing and washing and washing, and what's happening in the sink is all this clean dishes are piling up, but their drying isn't being done very quickly. So what I'm going to get you to think about is how these different contractors or brother and sister doing the dishes have their own rates. Every set of reactants that have to combine, every step in the reaction has its own rate. So when we say reaction mechanism, which is going to come up as its own phrase or term on the test, reaction mechanism means the steps, the inner workings of the reaction, the steps that is required to go from reactants to product. So let's look at it. If our first 2 steps is framing the house, putting on the roof, and then putting in a door, if those were our steps, the house with the roof and then the like walls with the door, these are called intermediates. Actually, not just for houses, but for chemistry 12. Your intermediates are molecules that aren't actually products. They're part way there. It also, step 1 is slow and step 2 is fast, okay? So in this case, the washer of the dishes is really slow, and so you're wanting to dry and you're standing there waiting to dry, but there's never any dishes because that person who's washing is really slow, and you're like, come on, hurry up. Okay, so that's important. It's going to matter later. Then you have a third step, which is also fast. These guys come in, they put in your weird hexagonal window, and now you have your house, okay? But the window guy couldn't do his job before the door guy for whatever reason. And the door guy couldn't do their job until the house had its walls, right? So everybody was waiting. So individual steps are called elementary process or processes. Each individual step in a reaction mechanism, the mechanism is all the steps that it takes. The individual steps are called elementary process or processes. Key fact for today, the rate of the reaction depends on the slowest step. So you're not done those dishes until lazy little brother does all the drying and they get put away, right? So the slowest guy, so your house, if you're trying to build a house, which I would not recommend, it takes really long and it's a lot of stress. It doesn't matter how good your window and door guy is until that roof is on. You don't have a house. And if that takes 6 months or something, then that's how long it takes for you to get your house. And then boom, boom, you got your window and your door, no problem, right? It's the same idea. The slowest step is ultimately what determines how quick a reaction is going to take place. By and large, again, roughly, right? So the overall reaction rate is only as fast as the slowest step takes. Therefore, we refer to the slowest step in the mechanism as the rate determining step, RDS.